Hello everyone, my name is Saida Zuhairi. I am a cybersecurity master's degree student at Grand Canyon University. This is a presentation and video presented for my professor Gary Lieberman on December 24th, 2025. My for my first hack part two, the this assignment called Penetration Testing and Risk Management CYB 610. The introduction. In this assignment, I demonstrate a controlled and authorized penetration test conducted against the Kubernetes level 1, which is the target, or let's say the victim. Level 1 virtual machine, which is the IP address 192.168.56.102, using a Kali Linux system, which is the attacker virtual machine, 192.168.56.102. Metasploit, I run MSF console. It turns that it's a version 6, not version 5. That was shown in video, but that should not make any difference. By following the provided instructional material in the video in the playlist, I accessed to the target machine. Access the target machine was obtained um, through an identified vulnerability in the Samba 2.2.1a service. Auxiliary scanner. The process began with network enumeration to identify available hosts and services, after which Metasploit framework was used to interact with the vulnerable service and establish access to the system. Samba version research. Next, an SMB scanning module was utilized to identify the version of the Samba service running on the target system. The scan was directed toward the identified host at IP address 192.168.56.102. The results of this scan revealed that specific Samba version in use, which was then independently researched to assess known vulnerabilities associated with that release. Google gave me this screenshotted outcome. Exploit database. I clicked the first result, and it took me directly to this page. Then I clicked this command next to the exploit to get to the page code. So I can copy it and use it in the next step. Root operations. I opened two root at Kali windows since I was not able to divide my screen horizontally. Then I ran vi 10.c, then pressed Control Shift and then V to paste the code I copied from the source page in the previous step, as shown in the next two screenshots. Then I saved it with this command, wq. After pasting the copied code from the previous step, I run is to list files, but I could only see the tn.c file because the rest of the file were in home and I was in root. I run gcc 10.c-o10 running ./10. After running this command ./10, I was able to see the root exploit and decided to use -b for brute force and 0 for Linux. The next slide will show the command that I used to target the Kubetrix. As I mentioned before, the Kubetrix is the victim or the target. To target the Kubetrix machine via IP address. And then here I started the hack here. This screenshot shows that my brute force hack has worked. And it's possible now to run the next set of commands to perform the hack on the target machine, which is the Kubetrix. I decided to use the ISAMD PWD commands to prepare the machine for the last step that is shown on this slide and the next one. Adding a user. In this slide, I tried to add a user to the target machine, which is the Cubetrix, to be able to log in to it. But I failed first time because I used the wrong command. Then I got the correct command from my professor, Dr. Gary Lieberman. He helped me a lot with this specific portion of assignments, and he provided me with the right command. And then I failed because of mistype. It was my mistake, but I learned from it. Then on the third try, I was able to succeed as shown in the screenshot. Hack was successful here as shown in my name, and this screenshot shows that I was able to log in. Now we have mitigation strategy and techniques. How to mitigate system, and what's the strategies and techniques that we need to take. System protection and risk mitigation. System security requires a continuous multi-layered approach that includes regular vulnerability assessment and the use of enterprise security tools to identify potential weaknesses across the infrastructure. Timely patch management and software update are essential to minimize exposure to known vulnerabilities and maintain system readiness. User access permissions must be carefully assigned according to defined roles, ensuring individuals have only the access necessary to perform their job functions. Enforcing the principle of least privilege reduces the risk of unauthorized access and limit the potential impact of security breach. Ongoing security awarenesses training is critical as a human behavior remains one of the most common sources of security incidents. Implementing identity and access management (IAM) solutions strengthens the authentications, authorizations, and oversight of user access activities. Mitigation strategy and techniques. Then here we have mm, account monitoring and security controls. User accounts and system activity should be continuously monitored to detect and report suspicious and unauthorized behavior. Administrative and high privilege access must be limited to minimum necessary and closely monitored to prevent errors that could result in significant security incidents. Organizations should enforce strict security policies that prohibit the use of personal devices, BYOD, which is a bring your own device, and forbid the sharing of credentials or sensitive information with unauthorized individuals. Multi-factor authentication (MFA) and strong password standards should be enforced, including regular password rotation to reduce the risk of unauthorized access and credential-based attacks. Buffer overflow. Buffer overflow vulnerabilities are among the most common security flaws exploited gain unauthorized access to computer system. These vulnerabilities arise from programming errors that fail to properly manage memory boundaries, allowing excess data to overwrite adjacent memory locations. By overwriting critical memory structures, an attacker can redirect the program's execution uh, flow to execute malicious code and compromise the system. Buffer overflow attacks can occur through various mechanisms and under different conditions, depending on how memory is allocated and managed. There are two primary categories of buffer overflow attacks. The first one is stack-based buffer overflows, which target buffers located on the call stack and are the most frequently observed. Heap-based, heap-based, the second type of buffer overflow is heap based overflows, which exploit dynamically allocated memory within the heap. Privilege escalation. Privilege escalation is a network-based attack technique in which an adversary exploits an initial weaknesses or vulnerability to gain unauthorized access to a system. Once initial access is obtained, the attacker attempts to increase their level of control in order to access additional resources and sensitive information. A privilege escalation may be achieved through multiple attack vectors, including systems misconfigurations, exposed services, or firewalls weaknesses, compromised credentials, and social engineering techniques. Privilege escalation attacks are commonly classified into two categories. First category is horizontal privilege escalation, where the attacker compromises another user account with similar access right to expand their control. And then the second type is the vertical privilege escalation, where the attacker elevates a privilege within the same account to gain higher level of permission. Rootkit. Rootkit is a form of malicious software designed to obtain and maintain unauthorized and privileged access to a computer system or network. Rootkits are engineered to conceal their presence, allowing attackers to remain undetected while exercising long-term control over the compromised system. Once installed, rootkits provide attackers with extensive capabilities, including system manipulation, persistence, and evasion of security controls. Rootkits exist in several forms, each targeting different components of a system. Bootkits, which infect the system's boot process, often targeting the master boot record. Firmware rootkits, which compromise system firmware and to achieve deep and persistent access. Memory. The third type is memory. The memory rootkits, which reside in violate system memory and operating without leaving artifacts on disk. Trojan or a Trojan horse is a type of malicious software that disguises itself as a legitimate or trusted application in order to deceive users into installing it. Unlike self-replicating malware, Trojans rely on social engineering and user interaction to gain entry into a system. Once executed, a Trojan can provide unauthorized access to sensitive data, enable remote control of the system, and facilitate further compromise. It may perform a wide range of malicious actions, including data exfiltration, system manipulation, and the installation of additional malware. Common categories of Trojan malware include backdoor Trojans, which allow persistent unauthorized access, remote access Trojans, RATs, which enable attackers to control systems remotely, fake antivirus Trojan, which deceive user with fraudulent security alert, exploit Trojans, which leverage vulnerabilities to execute malicious code. Backdoor. In everyday life, a backdoor refers to a hidden or secondary entrance that allows discrete access. In cybersecurity, the concept is similar. A backdoor is a method or gateway that allows access to a system by bypassing standard security controls. Purpose grants access to both authorized and unauthorized user, enabling high-level or root access. Impact provides attackers or system operators the ability to reach sensitive data at the top of the access hierarchy. Origins. introduced intentionally by software developer for maintenance or troubleshooting, installed maliciously by attacker, often through malware. Example, a Trojan is a type of malware that can function as a backdoor. Viruses. A virus is a malicious software designed to replicate and transfer between devices. Function. Self-copying programs spread through systems to cause damage and enable unauthorized access. Types of damage. Hardware attacks target components such as BIOS or CPU fans, potentially causing overheating and motherboard failure. Software attacks delete files or hide critical operating system files. Network disruptions duplicate extensively to flood network, slowing system performance and hindering activities. Examples: worms, trojans, ransomware, and other variants with similar goals of disruption and unauthorized access. Return-oriented programming. Return-oriented programming (ROP) is an exploitation technique used to take advantage of security vulnerabilities caused by memory corruption. Usage trend. ROP is less commonly employed today due to advancement in exploit mitigation technologies and defensive system design. Technical basis. ROP evolved from traditional stack smashing techniques and then mechanism exploits program bugs to manipulate execution flow and redirect control to the attacker. Common social engineering attack, phishing. A widely recognized social engineering attack aims to obtain personal information and credentials like name, address, SSN, social security number. Honey trap. Attacker pretends to show emotional or sexual interest in the target. Builds a virtual relationship to gradually extract personal information or credentials. May involve recording inappropriate material to demand ransom. Pretexting involves creating a fabricated scenario to deceive the target, used to request sensitive information under false pretenses, often results in identity theft uh, once the victim complies. And here's my references for my assignment today. Thank you so much for watching. Hopefully you like it. Have a great and Merry Christmas for all of you and your families.